Good morning, good afternoon, and good evening, depending on where you are joining us from. Welcome to Simplilearn. Welcome to webinar, Why Cloud Computing Makes DevOps Inevitable. My name is Martin Stufi. I'm your moderator, and also I will be mostly in the background helping Bernard Golden, our trainer for today's session, so that everything goes smoothly. During this session, all the participants will be on the mute mode to avoid the background noises. And now please go ahead and type a message in the chatting module. Just say hi or hello and let us know that you're here. This will let us know that you're hearing us and everything is connected properly. We have our trainer who will be conducting this webinar as Why Cloud Computing Makes DevOps Inevitable. And this is, as I said, Bernard Golden. You know that DevOps and cloud go hand in hand according to many experts, which means IT's use of cloud computing may make DevOps tools inevitable. And now, I would like to inform you that in order to improve our services, every feedback is essential for us, and we request you all to please take up the survey and provide feedback at the end of this webinar through the polling activity. Now let me to come and provide you as introduction to our trainer Bernard. I'm proud to introduce Bernard as a guru who will conduct this webinar. As I said, why cloud computing makes DevOps inevitable. Named by Wired.com, he's one of the 10 most influential person in cloud computing. And Bernard Golden is CEO of company Navica, a consulting firm focused on cloud computing and DevOps. It means, guys, that we have really guru on today's session. Bernard also serves as the cloud computing advisor for Simplilearn, the leading online training certification. As Simplilearn advisor, he provides guidance on cloud computing adoption trends, training needs, and curriculum development, as well as serving the public face of Simplilearn cloud training offerings. And he's chief examiner for the APMG Cloud Computing Foundation certification used to certify students across the globe. And now I would like to do the handover to Bernard Golden. And at the end, as I said, we will have a 15 minutes question and answer time. In the 15 minutes Q&A time, we'll cover as many questions as we can that weren't already covered during the session. If you hear something, some brilliant, interesting, insightful, and you want to share in your social channel, whatever your social channels are, as a Facebook, LinkedIn, Twitter, you can use the hashtag #SLWebinars. That way people can find it, that you will make them visible here. And you didn't come, guys, here to listen to me, and I'm proud to do the handover to Bernard, who will be your host on today's session, Why Cloud Computing Makes DevOps Inevitable. Go ahead and sit back, relax, have a cup of coffee, tea, or if it's evening, where you are at, maybe a glass of wine, and enjoy, guys. Thank you to all of you, and happy simple learning. Hello, Bernard. Are you there?
Yes. Hello, Martin. Thank you so much for that introduction, and thank you very much for inviting me to speak today. Why don't we jump right into it? Why cloud computing makes DevOps inevitable. And let's start with the state of the computing industry. Where is computing being done, and what does that imply about what IT organizations are going to do with their computing going forward? Well, in October, Amazon announced their AWS numbers, the Amazon Web Services numbers. They are at a quarterly rate of $3.2 billion at a 56% growth rate. So annualized, that comes to something like $13 billion, growing 50%-ish per year. That means next year, it's likely to be something like $20 billion. Just a week prior, Microsoft estimated its numbers for its Azure offering, and it's a little difficult to figure out exactly what those numbers are because they lump them in with other service offerings like Office 365, but analysts estimate that they're at about a $500 million to about a $1 billion run rate per quarter for Azure. but growing extremely rapidly, 120% growth. By the way, Microsoft announced its numbers for the fourth quarter of 2016 just a few days ago. And again, it was hard to figure out what the numbers were because they were lumped in with all these other services, but they announced that they were continuing to grow Azure at over 100% growth rate. And just by way of comparison to the rest of the industry, to give a sense of the magnitude of how these cloud providers are growing, VMware, which is a very well-established, well-known enterprise software company, in that same quarter did about $1.7 billion and about 6% growth. So if you look at it, Amazon is growing about 10 times as fast as VMware. It's nearly twice as large, growing 10 times as fast. And Microsoft, while not quite as large as VMware, is growing at something like 20 times the rate. So that gives you a sense of what's going on in the industry in terms of the growth of where computing is being accomplished or where computing is being executed. Now, if we look at what this is going to look like over time, we're in 2017 now, and these numbers annualized for the two providers, Amazon and Azure, will come to something like over $20 billion. But if you extrapolate their growth rates, around 50% and around 100%, over the next 3 years, plus the remainder of 2017, it means that Amazon and Azure will be running almost $100 billion a year of computing. That it represents an enormous footprint of the processing power of the industry. And we can get a sense of what this means for enterprise IT organizations by looking at a survey that JP Morgan did. JP Morgan, and this is from a business investment perspective. So this is the investment arm of JP Morgan, which is trying to understand what's going to go on in the computing industry as a result of cloud computing. So they went out and did a survey of 200 large enterprise CIOs. The average IT spend that these CIOs represented was around $600 million per year. Now that varied. So for some of them it was $20 or $30 million, and some of them it was several billion dollars. But averaged it was about $600 million, which is a very large amount of IT spend. And they said, the question they asked them was, what percentage of your applications currently run in public cloud environments? And what percentage will you be doing in 2020? And the answer came back that it was going to represent a dramatic growth in cloud adoption over the near future. Today, 2016, about 16% of enterprise applications were deployed in public cloud environments. But in 4 years, 2020, it was going to represent about 41% of all application deployment. So in other words, going on half of all enterprise applications were going to be running in these cloud environments. Now, they didn't ask the question, what about after 2020? Is it going to stop and plateau at 41%? Or does that 41% just represent a station on the way to 50%, 70%, whatever it might be? But what we can take from this is that for mainstream enterprises, cloud computing is going to become a very large proportion of the computing footprint. And that, in turn, carries dramatic implications. And that's what we're talking about today. Let's understand the difference between old infrastructure and cloud infrastructure to really recognize how dramatic the differences are. In the old infrastructure, you had to get capital investment up front. Typically, that meant you had to go request budget, make a large investment, a large purchase, and then you installed it. It could take months to availability depending on the budgetary cycle, how long it took to order the equipment, when it arrived, how quickly it could be installed and configured, and so forth. So from the point of view of time where you said, we need to do some kind of computing, it could be months before you'd actually be ready to start executing something. It was quite static. Typically, you'd install it, you'd say it's never going to change, it would be very difficult to change, and so it was very hard, if something changed about your application, to change the environment that it was executing in. It was hard to scale. If your application blew up and got 5 times the traffic you expected, you were in a world of hurt, because to get more equipment to support that load, you were back through the upfront capital investment, budgetary cycle, etc. Typically, these were managed by heavy processes. ITIL is kind of the classic example of what this would be. And change control boards. If you want to make some kind of an update to the application, it had to go through a process of approvals. Maybe that was done every couple of weeks, something like that. Really difficult to be responsive to the market. And of course, it was run all by manual operations. If you wanted to make some change and you got your change request approved, you then submitted a trouble ticket, someone put it onto a queue, and eventually got worked on. And that could be part of a long time frame, a lengthy delay. Cloud infrastructure changes this completely. There's low initial investment. I mean, you can start and just be paying pennies per hour to start computing. And that means you don't have to go through all of that budgetary cycle. You don't have to get large approvals. You can start computing immediately because it's minutes to availability. You request resources from someplace like Amazon or Azure, and literally within 10 minutes, they're there. And actually, it can be a lot faster than that today. You can actually go into Amazon or Azure cold. You don't even have an account. And within 10 minutes, have an account and have computing resources up and running. Those resources are dynamic, so it's very easy to change them. You can take resources down, add new resources, and so forth. And it's quite easy because they are run to be dynamic. It's trivial to scale. You want to add more computing resources to an application to handle unexpected load. Again, it's available in minutes. It's light process friendly, which means that you don't have to overload this very difficult kind of resource availability with manual processes that are designed to slow down making changes. And then, of course, it's automated operation. You issue an API call or something like that, and it happens in the background. No one has to touch the equipment. No one has to make any particular hands-on visit into the data center. Really quite dramatic difference in the way that infrastructure is managed. So what does that mean for DevOps? Well, let's talk about the great sage of Nebraska, Warren Buffett, one of the greatest investors of all time. And he has a saying where he says, only when the tide goes out do you discover who's been swimming naked. And he's usually applying that in an investing context, which means you may have a business that looks great when times are good and the economy's booming, but only when times get tough do you find out who's got a sustainable business offering. So only when one thing that you've assumed changes do you see what's going on underneath the covers or underneath the water. And I think that's a very instructive maxim for cloud computing, because the tech version of Buffett is removing one bottleneck exposes the next bottleneck. So in his case, removing that opaqueness of the water shows you who does not have sufficient safety in place if there's not water there protecting the view. Within tech, once you remove one bottleneck, it inevitably shows you the next constraint in the system. So removing one bottleneck exposes the next one. And to apply this maxim in our space, now that deployment speed is no longer the primary bottleneck, application development and deployment speed is now the primary bottleneck. So we've removed all of that friction that used to be present when you had to get resources, computing resources available. Once that's gone, the next thing that slows down being able to be responsive around IT is how fast can you develop and deploy applications? And that is a critical factor for IT. In a way, IT organizations used to have an excuse around getting things done quickly, because they'd say, well, it's going to take forever to get our resources. So if you weren't very good at application development, you weren't very fast, you weren't very sophisticated about the way you deployed applications, it kind of didn't matter because it was all overshadowed by the length of time that it took to really run infrastructure. Now that that's no longer the case, it exposes the challenges around application development and deployment. And that's what makes DevOps inevitable. Going forward, that is the reason that cloud computing makes DevOps inevitable, because now you have to focus on making sure that your application's development and deployment goes faster. So how do we go about addressing application bottlenecks? Well, we have to look at all phases of the application process, the application lifecycle, we might call it. So from a business driver, business organizations, business units, they want to accelerate innovation. They want to be able to bring new products and services into the market faster. So they want to be able to collaborate with IT to rapidly develop and deploy new offerings. They want to be able to do frequent releases to offer new functionality very quickly, to send out more frequent, smaller updates, more functionality improvements more quickly. They don't want to be stuck in the way that things used to be, which was because it was so hard to get resources, so hard to get things deployed, you tended to have big bang releases, very large conglomerations of functionality. With this new world, they don't want to do that. They want to be able to bleed out new incremental functionality to users when that functionality is available. And that makes it easier for users to adopt as well, because they're not being faced with gigantic changes when they get new functionality. And they want continuous integration. They need to have the ability to provide new functionality, expose new back-end features, new transaction types, so forth and so on. So they need continuous integration. Turning to DevOps, you want to be able to increase throughput. So now you've got good ability to develop applications, to have tight collaboration between business and IT, to develop new functionality, to do frequent releases. Now you want to be able to get them out into infrastructure. You want to be able to deploy them quickly. You don't want to be turning them over to somebody who says, well, I've got to do a rebuild, I've got to go create a new run book, etc., etc. You want to be able to increase throughput. You need automated operations, so a code change can be shifted into production with no one having to touch it, with no one having to run new processes, with no manual handover. You want continuous deployment so that a change, once it's improved to go into production, can be deployed in a matter of minutes. And then, of course, you need distributed monitoring and management. This is a world where, again, resources are quite dynamic. They're joining and leaving the application pool all the time. You need monitoring and management that are very flexible, that can accept new resources joining the application pool, start monitoring them, start tracking, make sure they're operating properly, start throwing off logs from them, and so forth. And you need that to be able to handle a distributed application topology. So that sort of says, I've got all the capabilities around fast development and fast deployment that needs to go into a cloud computing environment which helps you to boost efficiency. So infrastructure availability. Obviously, it doesn't do you any good if you develop very quickly, you're ready to deploy the system, and then you're back to that old world of infrastructure where it took months to get resources available. So you need infrastructure availability in a course of minutes. You need scaling, elasticity, and resilience to be in place, because again, these kinds of applications are turning from traditional back office applications, which needed good availability, but if they were down for a while, it just inconvenienced employees. These are now turning into the primary way that organizations operate with their customers, the primary way that users interface with companies. They have to be available 24/7. And so you need resilience built into the application so that they can be remain available in the face of a resource failure or even a data center going down. So you need scaling, elasticity, and resilience, and you need cost effectiveness. That's very, very important, because these are now part of the cost of goods sold, these applications. You know, you might be putting out a product. The example I use a lot is a Withings scale. A Withings scale is a scale that is made by a French company that not only tells your weight, but it also tells your body fat percentage, your heart rate, and so forth. It has an app that it talks to so that you have a track over time of what your weight trends have been and so forth. But it also has capabilities of being connected into your social media. And you might say, well, why would you want to have your scale broadcast what your weight is? But for many people who are in a weight loss regimen where they're trying to lose weight, having a peer group that can support them and can say, oh, I saw that you lost half a pound, way to go, is a very strong motivating factor. And so Withings has built that into their scale. So they've got a lot of computing behind this scale. And for Withings, they sell this scale for $150 or something like that. They've got to know that over the lifetime of that scale, that not only can they support the price of the components of the scale, but also all of the computing back end as well. So they need a cost-effective computing back end for that device. They need that application to be cost-effective so that they can make these scales at a profit and run them over their lifespan, which might be 10 or 15 years. So you need a cloud computing environment to be able to do that. And then all of that, the ability to develop quickly, to release more frequently, to run it in an efficient, very scalable environment, that really changes the dynamics of business itself. So it enables experimentation. When you're a business unit representative, like a product manager or something, you can say, it'd be interesting to see a tweak on our product if we offered, some new functionality or a new report. I mean, Withings might say, why don't we do something where we share this with your doctor and put out a formatted report that shows information relevant to your doctor. Let's try that out. And this whole application lifecycle that you've accelerated supports fast prototyping. They could put that up, try it with, say, 50 doctors and 100 users, and see how that's used. See if it helps make medical appointments more informative, or leads to better outcomes, or makes patients happier. You can do market trials, extend it into new regions very easily, and you can do fast follow-on. Oh, that thing with the doctors and the users and patients worked really well. Let's roll it out to 10,000 users and their doctors and see how it goes. So it enables fast follow-on. So there's kind of a virtuous cycle that getting all of this right really helps improve business outcomes. And again, if you just have the cloud computing part of it without the Agile and DevOps piece, you're really not improving things, because even though you're really fast with infrastructure, you're really slow with the application. So that's why DevOps becomes inevitable in this world. So where does that leave us? Well, DevOps means automation, right? And it does, but it requires the right kind of automation. On the left is the original assembly line, Henry Ford's assembly line. And they're building this, but it was really a matter of putting work in front of workers who still perform manual tasks. And so it was much more efficient than what had been present in the previously. But it still required a lot of manual intervention. On the right is today's assembly line, and you can see that for this portion of the assembly, there are no humans present performing this work. There's no one welding panels. It's all being done by robots. And that's really the vision of what DevOps is. It's not automatically bringing work to people who then perform manual tasks. It is figuring out how those tasks can be automated themselves and placed into processes that are executed dynamically, automatically, by a change of a status, by an event being triggered. So DevOps does mean automation, but it means how do we have automation all the way through the life cycle so that no one has to touch it. What we're trying to avoid is what I call silo automation and manual handoffs. And this is where you've got a situation where, for example, someone in the operations group, the infrastructure group, has written scripts to automatically create virtual machines, which is great. But the trigger for needing a new virtual machine is maybe someone says, I'm ready to roll out a new test version of my application and I need to run some stress tests on it. My code is ready, and the person says, I'll trigger off this script to put up my virtual machine. Okay, the virtual machine is ready. Now point me to where the code is so I can go manually install it. You've got a silo automation there. One group has automated their task, but you haven't automated inter-organization. You haven't automated the entire process, and that's a common problem. You get groups saying, I'm going to make my work more efficient, but without any sense from the organization itself of how do we streamline the entire process. And so you get this kind of herky-jerky start and stop. Oh yeah, my part's all done. Now I'm waiting for the next group to take the handoff. And that might even be triggered by trouble tickets. So you're back to that old trouble ticket driven model. That's not super helpful. The model that we really want to look at is intergroup automation. How do we get each group able to hand its piece off to someone else that is already prepared an automated acceptance and execution of their processes, and then an automated handoff to the next one. So how do you go from where development finishes a code change, it automatically flows through to a QA process where there are tests that are automatically executed, and once those have successfully passed, it moves on to staging, where additional testing might be done or integration testing might be done. Once that's passed, and that's done all automatically, it flows through to operations, which has the ability to automatically trigger changes into a dynamic infrastructure. So the motion is you really want this kind of bucket brigade where things flow automatically. That's the solution that we want to look at. So the DevOps journey is really a three-phase process. It's analysis, implementation, and then operation once you've got the system in place. So analysis is identify your forward-looking infrastructure. Where are you going to be placing applications? And as we saw earlier in this webinar, increasingly that's going to be a cloud-based environment. And then go through a process called value chain definition. And I'm going to talk about value chains next slide. But in other words, what are all of the steps that we go through from someone making a code change in our application to it actually up and running and someone able to access it, some user being able to access it? Implementation is, okay, we know what we want to do. How do we do it? We identify our automation tools. We map the inputs and outputs of each of those tools. We select and design the tools that we're going to use to glue those automation tools together, and then we test and move into production. We test the system to make sure it's going to work, and then we start using it for real-world use. And then within operation, we want to have the ability to do very flexible kinds of deployments, canary, A/B testing, incremental growth deployment, and I'll define these a little bit more in a few slides, and then implementing rollback functionality. Now, the traditional model of IT was you made a change, you rolled it out, and you assumed everything was going to go well. Well, guess what? Everything doesn't always go well, does it? But we didn't really have very good ability to say, oh, that didn't work. Let's go back to where things were in the previous state. In fact, for most organizations, to back out a change was a manual intervention that there weren't very good guidelines for, and so it was almost like a real-time firefighting experiment, and very challenging, often led to extended outages. We don't want that, so we want to have the ability to do automated rollback functionality. So analysis, select your future infrastructure choices. You know, what cloud environments are we going to be using? What functionality within those cloud environments are we going to be taking advantage of? How are we going to be able to use those services? This is the services that we're going to be needing, and these are the APIs and interfaces by which we access those services, so we need to be able to automate being able to deploy into and run in those services. What are the automation tools that we're going to be using? We're going to be using Chef or Puppet or Ansible, or maybe we're going to be using Jenkins as a way to take code changes and then call testing and so forth. You know, figure out what are the right tools for us. And I always say it's good to take those and do an analysis and choose one through a deliberate process that the whole organization participates in. Oftentimes, these kinds of DevOps things are done as skunkworks operations, where someone makes a choice based on a tool they used at their last job, or something that they've heard is really good, or they just want to try something new to learn new skills. All of that's very admirable, but the problem is you end up then with one group has their DevOps tool chain done with this set of tools, another group has a different set of tools in their tool chain, and that's a recipe for problems because applications then all have to be managed differently. It's very difficult to transfer people across groups because they have to learn entire new skills and so forth. It tends to impose high operational costs through the overall organization. So, our recommendation is to identify and select automation tools that should be used across the organization. This can be challenging, requires more planning up front, but it pays tremendous benefits downstream as you get efficiency across the entire application lifecycle. Mapping the inputs and outputs. If you're using Chef, what are the calls that you make to deploy a new server or a new container? Likewise, if you're using Puppet, what are those calls that you make? And what are calls that you then can make into the configuration management system to pull code out and install it into that new virtual machine, that new container? You need to have an understanding of all those inputs and outputs because you want to get to a place where you automate the calls through those inputs and outputs. So you need to understand them. So you need to map them. So if I'm making calls into Chef and it executes, what are the outputs that it will put out that I need to then pass on to the next part of the process? What kind of objects will it hand out? What kinds of event triggers will it put out? And so forth, so that you can then map those as an input into the next step of the process. Selecting design and integration tools, and those need to work across public cloud and internal infrastructure. Hopefully, you'll get tools that can map across both of those. It's not that convenient to have two different kinds of sets of tooling. It may be unavoidable. Are you going to be using virtual machines or containers? Again, that will change the tooling that you can use because some tools are great for virtual machines. Some are identified as being appropriate for containers. Others try and map across both. You need to make a decision about that. And of course, it depends on what your overall direction is. Are containers going to become a big part of your computing environment? Well, you need to plan for that as well. And really coming up for many IT organizations are serverless type environments where you use so-called functions as a service. You need to think about how are you going to deploy those code fragments. And then some sort of an orchestration framework. Kubernetes is one that's quite popular for containers. Virtual machines, you might use either a third-party tool or you might be using something like Elastic Beanstalk from Amazon. You need to figure out what the orchestration framework is because that's what's going to be managing and monitoring the application deployment environment. And in terms of the value chain definition, the value chain is a very important part of the process. Many IT organizations rely on kind of tacit knowledge. Someone joins an operations group and gets told, this is where you go to get your code, or this is how you implement, this is how you deploy code, or this is who you go request something from. And it's all very undocumented. It's all very unknown. It's not even necessarily known if it's particularly efficient. It may just be the way that something happened 3 years ago because one particular operations engineer said, I'd like it done this way. And that spread through the operations group and then spread upstream to other groups. It may not be efficient. It may have extra steps. It may be imposing bottlenecks because it all has to flow through one person, who is the person who approves work or whatever it might be. So the value chain definition is you go through and say, what are all the steps in the current path from development to deployment? Who is everyone that touches this code change? What do they do? You identify the necessary and unnecessary ones. So, are there things that we're doing that really don't help this process? Do we have a local CMDB and then the corporate CMDB? You probably don't need two. You shouldn't have two. So maybe one of those needs to be removed. So that might become unnecessary. So select necessary and unnecessary. Going forward, you say we've got to incorporate all the necessary ones, and we've got a plan to obsolete all of the unnecessary ones. Let's get them out of our process because just extra work. It's not very efficient. It requires additional maintenance of integration and so forth. And if it doesn't help, let's get rid of it. Group and ungroup. You might be able to say, these two current separate steps could be combined into one thing with the tool that we're going to use. Let's group those. Let's accomplish them all in one step. And then define the inputs and outputs. And I've talked about the APIs and the events and the objects and so forth. That's what you're going to be looking at, defining all that. The value chain, coming out of that, you say, here are all the steps that are necessary. Here's all the inputs and outputs from those various steps according to the tools that we selected. Okay, now we know what we need to build for our DevOps tool chain, our DevOps flow. Let's go ahead and implement that. You've identified the automation tools. Some might be partly dictated depending on what environment you're using or other tools that you've got, and partly chosen. Ideally, you'd like to find tools that are already integrated or already have pre-built integrations with the tools on either side of them. So in other words, instead of you having to take on the responsibility for building that integration, wouldn't it be great if the tool you choose already has an integration built for the tools that it's going to have to integrate with? And this is, Jenkins, for example, has many pre-built integrations. So when you decide to have it connect to Selenium for unit testing, it's already got integration. You still have to configure that integration, but you're not having to write code to get information from one tool to another. So seek tools with pre-built integrations. Look for large ecosystems. Going back to Jenkins, very large ecosystem, lots of people who use it. There's lots of use cases being put forward into the people who build it. So it's like it's a rich execution environment. It's got lots of functionality. It's validated by many organizations using it. It's easy to find skills out in the marketplace if you need to hire people in to run that. So it's very it reduces the friction to adoption. So look for large ecosystems. Avoid premature enthusiasm. Don't install a tool, say, oh wow, it looks really great. That's what we're going to do going forward. Be deliberate about this, and make sure you understand what you're getting yourself in for. Map the inputs and outputs. We've talked about that. Each tool must receive, send automated data, event triggers, and logging. Logging is extremely important in this world because if something doesn't go well, you want to be able to identify where did it fail, what caused it to fail. Oftentimes you have to do root cause analysis because what appears as the symptom of the failure is not the actual cause of the problem. You'll need to go back through logs to identify where did the first failure occur and what tool or what process or what part of the code did that. And ensure that you've got input-output mapping alignment. This is sort of the famous. You want to make sure that what the downstream tool requires, the upstream tool can spit out. Select or design your integration tools. You want tools that can be easily integrated with automation tools. You want tools that support common data formats, support common types of calls, and so forth. What's really important about this is to recognize that your DevOps toolchain is now an application itself, and it requires maintenance and investment. You're going to have people who are experts in this, who run this, who make sure that it's maintained, that if you have a particular tool in the toolchain and it's updated, that you have a way of taking that new version of this tool that you're using, validate it, make sure that it operates, make sure the integrations still operate correctly, and so forth. So they're going to have their own set of people, their own set of environments where they can perform tests, that they can make code changes to the tools or the integrations themselves, validate they still work, validate they can scale. So this is now a new application that you need to maintain. and need to recognize that it will require ongoing budget and investment as long as you're using it. So, the flip side of this great new automated system is it's an application itself, and you need to be able to devote resources to maintain it. And don't make the mistake of saying, well, we got it built, let's pull all the people off of it, and it'll work automatically forever going forward. No application does, and this application, this DevOps toolchain is no different. Test and move into production, validate with segregated applications. So start with a single application, start with an application that doesn't have a lot of other integrations that depend on it. Train the affected personnel. People who used to do things manually are now going to be doing them automatically, or they're going to be using a new tool to perform their function. Make sure they know how to use it. Make sure they're capable with it. You don't want to do a cold switch to a new tool and then have people go, God, I don't really understand it, and it's not working properly, and I don't really know what's going on with it. I better start, going online and Googling problems. That's not a good situation. You want to require it for new applications. So all new applications are done the new way. No exceptions. And if somebody says, well, it's a new application, but I'm more comfortable doing it the old way, I think I'll do it that way. No, because that's just going to mire you in more of the old way of doing things, more of the slow bottleneck that you've had in place. No, you want to require it for new applications. And then, for existing applications that have significant ongoing maintenance activity, it's a very viable strategy to say, this is an application that only has trivial changes every year. Why make that investment to automate all of that if it's so infrequently changed? I wouldn't do that. So, but if you've got applications that have significant ongoing maintenance, that they're getting new updates frequently, that they require new changes because of business reasons, legal reasons, whatever it might be, it makes sense to go back and invest in them to bring them up to this new automated system, because they're going to be an ongoing set of changes. They face the bottleneck of application development and deployment. Make the investment to ease their ability to move to this new environment. Operation. Well, low friction deployment will be accompanied by some percentage of poor deployments. What does that mean? Well, once it gets easier to do something, you're going to do more of it, and you're going to have some percentage that aren't good deployments. I mean, you're going to encourage experimentation. Well, guess what? Not all experiments work. Not all experiments pan out. You want to fail fast. You want to put it out there, learn from it, and if it goes well, you want to be able to put the pedal to the metal. If it doesn't, you want to be able to fail fast and say, that was an honorable try, but it didn't work. Let's pull it out. And you want to reduce the cost of failure. So you want to encourage business experimentation, because that's the new world we're in. So you're going to have some percentage of poor deployments. You just need to understand that and recognize that, and understand that you're going to be in a situation where you have to back changes out. So agile operations is a two-way street. There's deployment and rollback. And unless rollback is easy and cheap, DevOps is incomplete. Meaning, if you're really good at deploying changes, but if something didn't work and you need to back it out, you're back to the old, oh, we're in a fire drill, let's call everyone up, they've got to come in, they've got to start figuring out what code changes were made, figure out manual interventions. That's a big problem. So you need to have the ability to, just as you want to be able to press a button to deploy something, you want to be able to press a button to undeploy it. And the deployment patterns you want to support, Canary is, comes from canary in a coal mine. You put something out there to see how it works. So you might deploy a code change into just one machine to make sure that it really works in your operations environment. So a canary deployment is, we're going to put it out there and see if it stands up and works properly. A/B is, we're going to put it out to some proportion of our users and see what the adoption is. For example, Netflix does this all the time. They'll make a small change to their user interface to see if it increases engagement, increases the total minutes viewed, and so forth. And they'll put it out to, say, 5,000 users, and let another 5,000 continue the way things have been, and then look at the relevant stats for that pool of 10,000 and say, oh, the new change actually reduced the number of minutes that people use, so it's not a good change. So you're doing testing. So you want a deployment pattern that can say, make this available to the next 5,000 people who come in, or spread the next 10,000 people across these two options so that we can validate the statistics. Incremental growth deployment is, Netflix is a good example of that. We added a million new viewers. We need more computing resources in our application. So supporting incremental growth, we need another 10% execution environment up and running, and it needs to be joined into our pool and so forth. Your operations, your DevOps needs to be able to support that. Blue-green, which is a model that says when we put out a major code change, we actually stand it up on mirrored infrastructure, make sure it's up and running properly, and then redirect our DNS to the new environment. So we go from blue, which is the version, say, 1.2, to green, which is 1.3. At one point, we have both of them up and running, but all traffic is going to the blue deployment. We make that change, we flip the DNS, and all of a sudden traffic all shifts over to green. You want an operations environment that can support that. And this is typically accompanied by application analytics. Netflix is going to be looking at, the relevant stats. What was the total time of engagement? Did people click on certain kinds of shows more, so forth and so on. So you've got application analytics to not back up, but to figure out, did those changes that we've made make sense? Should we roll them out to the rest of the application pool, or should we back them out? And then implementing rollback functionality, you want to be able to ability to restore to pre-deployment status. So yank out all those changes. It brings confidence and boldness. What do I mean by that? Well, it means that if you know that you can put a change out and then pull it back if it doesn't work or turns out to be non-useful, that makes you more courageous. That makes you more willing to experiment. That makes you more likely to put changes out there. Typically, the one gotcha around that is storage schemas, because once you put out a storage schema, it's very difficult to change it back. It can be quite difficult. So you've got to be very careful around your storage schemas so that you've got the ability to take those new fields that you needed for the new functionality and still leave them there, even though maybe they're not being used if you do a rollback. So in conclusion, after cloud, the application lifecycle is the primary bottleneck, and many IT organizations will confront this as they start to adopt cloud, because what's going to happen is business users are going to say, oh, you started using the cloud. That's so fantastic. Resources are available so fast. It's so great. You can, it's very elastic and all that. How come it still takes us weeks to get code changes put into production? Why is that? Then it's going to become clear that the application lifecycle is a primary bottleneck. DevOps is a journey with iteration. You're not going to get it right the first time. You're going to find incremental improvements that you can make. Figure on that. You want to do both intra and inter-task automation. You don't want to end up with automated silos. You want to reduce the cost of deployment, how much work it is to make a change, to make a code change, to accelerate change, to enable business experimentation, and reduce the cost to roll back to encourage experimentation. All right, well, Martin, that is our webinar. That is the material. Do we have questions that have been put forward that we can address?
Okay, Bernard, it was really great. I just follow our attendees and try to recognize their questions. Unfortunately, they don't have a question, but now let me to open our polls activity, and after that, I will try to ask you an example question by my side, or you should go and make some summary about the today's webinar. It's up to you, but let's say that we have last 8 minutes, and I would like to open this polling activity, and after that we will decide what we're gonna do. Okay, you should make summary, or I will ask you a question or something like that. Okay, now I would like to ask our attendees to to use this quick poll activity and to provide these responses to us, because as I said, this is also quite important. And during this polling activity, I should say that it was really great presentation. As I said, this is first time that I'm with you, Bernard, on cloud presentation, and really enjoyable and very great information I got from you, especially when you explain an example, Warren Buffett's lessons, or when you compare all the infrastructure versus cloud infrastructure, very good things there. And let me to go and through the question, and our attendees ask for the presentation as a material. I think that we are not able to share this presentation with our attendees. This is a kind of webinar. Primarily concept for that is to show to our attendees how to go and move to the next step. But this is a, let's say, case that I would like to ask you, Bernard, what's after, let's say, this webinar as a question from our attendees, what they have to do after that to go and register themselves to some session with a training, or could you explain something about that a little bit, please?
Well, first, I believe that this webinar was recorded and will be available for people to either review or to share with other people. Isn't that right, Martin? So that they'll have access to the material subsequent to this webinar.
Yes.
So it will be available.
Yeah.
You know, this move to cloud and this move to DevOps is a big change for organizations. I've been involved with many organizations going through these process changes as they move, and it requires significant. It represents a very different way of doing things, and just to kind of go back to that auto assembly line. I mean, when Henry Ford put together that assembly line, previously the way people had built cars was basically, people like you, like me, or any of the attendees would just have a big stack of parts, and they'd walk over and they'd pick a part up, and then they'd walk back and attach it, and everybody did everything. And that was not very efficient. The assembly line, as it was put into place, really required skill changes because people stopped doing everything and started focusing on, I'm going to be the person who, attaches the carburetor to the engine, or I'm going to be the person who installs the seats. And it was a very different skill set. And, the assembly line itself really emphasizes that incremental change that I was just talking about, because it wasn't like Henry Ford just put together that first assembly line and that was it. He tinkered with it over years to continue to improve it, to continue making it more efficient, to streamline the activities. And he, over time, made the process more and more and more efficient. And that's sort of a lesson for all of us, is that originally a Model T cost around, I think, about $800 or $900 in those days dollars, which were a lot more than $800 or $900 today. But through the process of all of this efficiency, continue to tweak the assembly line, continue to make incremental improvements, he eventually got it down to about $250, $295, something like that. So, it was 1/3 the cost. And guess what happened? Lots more people bought cars. So, volume went up. And that's the kind of thing that we'll see around this kind of streamlining of the application lifecycle. People should expect that. So, learning new skills is really critical. And the way it was done, 5 or 8 or 10 years ago was somebody said, I'm going to go learn, I'm going to go online, I'm going to go read some blog posts. That's inefficient, and it doesn't scale, and you end up with somebody saying, I know how to do this way, and I know how to do it this. And somebody else says, I know how to do this a different way. You want consistency for the reasons I outlined. So, going through training, structured training that of the type that Simplilearn offers is the best way to go about making this change within an organization, making it consistent, and making it occur more rapidly.
Okay, thanks a lot, Bernard. And I would like just to come back to the question I had referring to the next step. It means after this webinar, what is the next step for our attendees as your recommendation as a trainer and guru in cloud stuff and so on?
Well, really, it was what I said. Identify a particular application, make sure that you've got the skills in place to put that application into a cloud environment and surround it with a DevOps capability. And really, that's requires making sure that your people are educated and trained up to speed. So choose the right application, make sure that you've got the right skills in place through training, and then go ahead and execute and use that as a learning experience. So, not only do you do the application, but you make sure that you draw out organizational learnings from it that you can then spread throughout the organization.
Okay, great, Bernard. And because we don't have any other questions, let me now to close our polling activity, and let's say that we should come to the final stage of our webinars today. We're running over, let's say, the time scheduled for more than 3-4 minutes, and let's do the summarize of that in case that you want. Otherwise, we should go and close down this webinar. It was really great and enjoyable, especially for me as your assistant or moderator. And please, Bernard, now just make a summary of that, and we should go and close this webinar.
Right. So let me just conclude by saying that cloud makes DevOps inevitable. That was the title of this webinar, and I think it really is the theme that attendees should take away. By taking advantage of cloud computing, which you will, according to what JP Morgan says, you will be forced to examine your internal processes and tooling. And that's going to be an ongoing investment. You need skills and so forth to accomplish that. This will help you help your business become more effective, because they'll be able to roll things into the marketplace more quickly, experiment, launch new products, and so forth. And you want to be sure that you've got full support for the lifecycle, meaning not only can you develop and deploy quickly, but you can also roll back as well. With that, Martin, I think that we're concluded, and maybe you want to go ahead and conclude the webinar.
Okay, thanks a lot, Bernard. It was really great, as I said many times. Now we are really at the end of this great webinar related to the cloud, and now I think that is pretty clear why cloud computing makes DevOps inevitable, as you made great explanation about that. And let me to tell you good morning or good afternoon or good night, depends where you are. And this is end of this webinar. Thanks a lot, Bernard, and good night.